In this tutorial, I will solve two questions on differentiation. Do well to trace back to my previous video where I made an introduction on what differentiation and function is all about, and on the general formula method of finding the derivative of a given function. I will drop a link below the description to help you to find the video. Let's read out the two examples we have on the board. The example number 1 says, if y is equal to, in bracket, 1 plus x raised to the power of 2, we are then asked to find the y dx. That means we are asked to find the derivative of this given function. Then for the example 2, we are asked to find the derivative of f of x, which is equal to 2x in bracket x squared plus 3. Let's go ahead to solve the two questions. We are starting with the first example, solution. The first example, we have that y is equal to, in bracket, 1 plus x raised to the power of 2, right? First of all, let's open up this bracket before we find the derivative for the function, okay? So we have that y is equal to, the square here simply means we must multiply this expression into two places, okay? That is the meaning of the square here. We must multiply the expression 1 plus x into two places. So let's go ahead to do that. 1 multiplied by 1 will give us 1. 1 multiplied by x will give us x. Plus x multiplied by 1 will give us plus x. And plus x multiplied by plus s will give us plus x squared. Okay? Let's go ahead to add. We have that y is equal to, we have 1 plus x will give us 2x. Then plus, we have x squared here already. So let's rearrange this equation such that we have that y is equal to, we have x squared, let's take x squared first, plus 2x, then plus 1. Okay, let's go ahead to find the derivative of y with respect to x. That is differentiating y with respect to x. So I will then say that dy dx, that is differentiating this function y with respect to the x. Remember that the general formula for differentiation says that whenever we have a given function, assuming y equal to ax raised to the power of n, where the a and the n, they are the constants, then the y and the x, they are called the variables. So whenever we have a given function like this, to differentiate it, we then say differentiating y with respect to x will then be equal to multiplying the term ax raised to the power of n, multiplying it by the original power of n. Then we subtract 1 from the original power of n. This is what we call the general formula for differentiating a function or finding the derivative of a given function. So that is what we want to apply here. So differentiating y with respect to x will be equal to, we shall multiply x squared. We shall multiply x squared by the power of 2. Then we subtract 1 from the original power of 2. Okay? Then plus, the same thing we shall also do for here. We shall multiply 2x by original power. Remember that x has invisible 1. We shall multiply it by the original power of the invisible 1. Then we subtract 1 from the original power. Don't forget that every natural variable has an invisible 1 attached to it. Once a variable does not have any power it is raised to, it has an invisible 1, because x raised to the power of 1 is still x, okay? So there is an invisible 1 here, such that we subtract 1 from that invisible 1, then we multiply the term with the original power of 1. Then plus, Remember that when you differentiate a constant, you have 0. So differentiating 1 will give us 0. Okay? And this is equal to 2 multiplied by x raised to the power of 2 minus 1 will give us 1. Then plus 1 multiplied by 2x will still be 2x raised to the power of 1 minus 1 will give us 0. Then plus 0 is still everything here, okay? And that is equal to 2x raised to the, any number raised to the power of 1 is still that number. So we have 2x. Then plus 2 in bracket. Remember that one of the basic laws of indices states that any number raised to the power of 0 is 1. So x raised to the power of 0 is 1. So we have 2x plus 2 multiplied by 1 will give us 2. So here is the answer. Hence, our dy dx is 2x plus 2. Let's go ahead to solve for the second example, which says find the derivative of f of x, which is equal to 2x in bracket x squared plus 3. Okay? This f of x is the same as the y here. Why do they usually put f of x in place of y sometimes? The reason is because whenever you have a function y equal to ax raised to the power of n, I already told you prior that your x and the y are your variables. Y, the x, is an independent variable and the y is a dependent variable. That means y depends on x to have its value. Okay? And because y is a dependent variable, it depends on x to find its value. That's why sometimes we show that it is a function of x. That means the f of x here, is the same thing as your y. Because you cannot find the value of y without plugging in your variable x or the value of your x variable, okay? That is the meaning of this. That means f of x is the same thing as your y. But since we are given f of x equal to everything we have here, and we are asked to differentiate it, we shall not say dy dx again, but we shall say f prime of x, though we are coming to that. Let's open up this bracket first of all. We have f of x, which is equal to 2x multiplied by x squared will give us 2x cubed. Then plus 2x multiplied by 3 will give us 6x. Okay, such that to find the derivative of this given function is very simple. That means we shall say f prime of x. F prime of x is no more dy dx again, but f prime of x. F prime of x simply means the first derivative of this given function, okay? So differentiating this function is simply the f prime of x, and that is equal to, we shall multiply 2x raised to the power of 3. We shall multiply it by the original power of 3. Then we subtract 1 from the original power of 3. That is the general formula for differentiating a function. Then plus, here we have 6x raised to invisible power of 1. Every natural variable has an invisible power of 1. So we shall multiply this 6x raised to the power of 1 by the original power of 1. Okay? Then we subtract 1. We subtract 1 from the original power of 1, such that f prime of x is then equal to 3 multiplied by 2 will give us 6x raised to the power of 3 minus 1 will give us 2. Then plus 1 multiplied by 6 will still give us 6x raised to the power of 1 minus 1 will give us 0. Okay? So f prime of x is then equal to, we have 6x squared plus 6 in bracket. Remember, by the one of the basic law of indices states that any number raised to the power of 0 is 1. So x raised to the power of 0 will give us 1. Okay? Such that f prime of x will then be equal to 6x raised to the power of 2 plus 6 multiplied by 1 will still give us 6. So the f prime of x is what we are asked to find, which is the derivative of this given function. So our answer is 6x squared plus 6. Thank you for viewing. Thank you for watching. If you found this video useful, remember to reshare this video. Also like my Facebook page and as well subscribe to my YouTube channel for subsequent math content of this kind. Remember to reshare this video. Goodbye.